Okay guys, welcome to my channel, or welcome back. So we're looking at section 1.1 from Text and Text 4. So what are polynomial expressions? Well, let's just start with a few examples. 7x to the 5 plus 3x to the 4 plus 2x squared minus 7. Okay, is an example. So the coefficients can be positive and negative. They can even be fractions or even irrational. But these values here must be non-zero. Here you have x to the 0. Okay, but they can't be negative, and they must be whole numbers. They have to be positive, non-negative integers. Okay, let's just jump into a few examples. So to expand this, we'll just do this in a tedious way, and then I'll show you some other strategies. So we're going to use distribution. Okay, and then I join up the like terms. Group together the like terms. In other words, add or subtract, whatever the case may be. Okay, and that would be the final answer for the first one. Okay, I'm going to clear that. So 15x cubed plus 6x squared minus 41x minus 4. Now I'll clear that, and we'll do the second one using a place value strategy. Okay, so here's what I mean by a place value strategy. I'm going to align the x to the 4s x to the x to the 3s, x to the x to the 2s, x squareds. Now I'll think carefully about where 32x to the 4 goes. Where minus 8x squared go. And where minus 12x goes. And now the grouping has become a little bit easier. That's the answer there. Okay, now this is where our place value strategy will come into its own. So I'm going to do it with the variable factors in there, and then I'm going to strip them out. Is that multiplication? Now this one, now this one, now this one with a 0 here, and I need a bit of space on the left for 2x to the 3. And now the place values are very convenient. Now I'm going to do it without with the letters in, because I'll just understand that that's in a column of x squared. And this is exactly how our number system works, so it shouldn't be very confusing for us. The x here is worth 1, and you've minus 5. And this will remind you of just long multiplication. Except you don't have to carry, and negatives are fine. And then, as well as adding here, I can include the powers of x. Okay. Now I'm recognizing this as 25 and 16 means 5x plus 4 has to have been squared, because the root of 16 has to go here and the root of 25 has to go here. That's true. The identity will say ax plus b to be squared is a squared x squared plus 2abx plus b squared. So you're looking for the square root of b squared. So this is correct. And now double the bases is in the middle, which means p is equal to double the product of the 5 and the 4. So p is 40. It could have been minus 40, but they've indicated that it should be positive. So that's the answer there. Okay, I'm going to do this in a quite a clever way. You may not have seen it done this way before. Yes, there's a naught x squared there, but I don't really care. Put it in if we want. We just put it in here, a different color. But it's not necessary to do that. Very important that that's minus 11x. You'll see in a moment why. And this is plus 6. Okay, and I'm going to, there's a 4x here, it's not that important, and minus 3. So I'm going to divide the ends, give myself x, and divide the ends, giving myself minus 2. Okay, now this is a numerator, denominator, and this is a quotient. So the quotient by the denominator should be always equal to the numerator. So if you want to knock yourself out and check that that's true, that this multiplied by this is equal to that, then you should go ahead and do that. You'll definitely get minus 8x on this, and you'll get minus 3x on this, giving you minus 11x. And you'll get 4x squared. You'll see that there's no x squared, it's minus 4x squared. It does work, but in leaving cert, that will always be the case, especially when they've phrased it like this, that you're not expecting a remainder. So divide the ends often works. And when it doesn't, when it's a cubic over a linear, you have to include an undetermined middle term until you find it, and we'll have plenty of practice with them too. So coefficient of x squared is 3, the coefficient of x is minus 9, and the independent term, that's the constant term, is 5. The degree is 2, 3, and 4, because the highest power is 4. This is not a polynomial because there's a 1 over x term, which is not allowed, and there's an x to the 3 over 2 term. Neither of them are positive whole number powers. So to simplify is to group terms, and it's good manners to put them in descending powers, which we've done. See, I'm trying to organize myself with place values arranged vertically. I've done a decent enough job that I'll be able to work it out. Now this is where I'm going to use my place value, but I'm going to put things underneath each other. In my opinion now, there might be just a bit too many questions here that are repeating in skill level. Yeah, more of the same. Let's skip them. The important thing here is the square term and the constant term are very easy to determine, and then you can do your rainbow here with 8x and 5x is 13x. Okay, we know we're getting 2x squared minus 6, so this, the middle term, the linear term, is 6x, take 4x is 2x. I'm a bit surprised on that there's a common 2. I must have made a mistake somewhere, did I? 3x take 4x is minus x. Okay, and the very fact that I spotted that is a kind of a fact that if there's a common term across them all, then there'll be a common term across one of these. So my mistake caused me to check something, and that highlighted my mistake. Now again, the only complicated term is the grouped term, the linear term. We're getting 9 on the outer rainbow. Take 2 is 7x. The quadratic term does not involve grouping. It just comes from firsts. And the independent term, the constant term, comes from lasts. Quadratic term is 12x squared. The linear term is minus 8 minus 3, which is minus 11x. And then we have 2. Quadratic, 15 take 2, independent. Quadratic, 24 add 2, neg 24 add 2, independent. Difference of 2 squared, difference of 2 squares, difference of 2 squares, perfect square, perfect square, perfect square, always ending in a plus. Another perfect square. Now 2 times 2 is 4, AB, And then you've plus 4b squared because you squared a 2 and a b. Always a perfect square ends in positive. So here you're taking double the cross product okay, which is 12. It's getting a bit messy here, but double a half is 1. And square of a half is a quarter. Park the 8. Double the quarter is a half. Squared a quarter is plus 1/16. And then come in with your 8. Park the half. You can square x minus 1 or 1 minus x. It's the same thing. With square x minus 1, you'll get x squared minus 2x plus 1. You negate each of them. So perfect squares should be even in the middle. No. Okay, this will have started off with 3, but it can't have negative here, so no. This looks like it's right. You'll have had a 3x here and a 2 here. And 3 by 2 by 2 is 12, yes. So that's a perfect square, the rest aren't. So for this to be a perfect square, this was 2 times 2x. Which is quite tricky. That means the square root of 2 is what p is. That was nasty. And I presume it says p can be any value, including irrational. So this is fine. You've got 5x and 2 to be squared. So 2 5s is 10 and double is 20. So t is 20. What am I looking at here? S. So basically you've 3x and then you've 2 times 3x times whatever the base of s is. Okay, but this is 6. Root s is 24. Root s is 4. S can be positive or negative. Plus or minus 2. Hold on, root s is 4. Square both sides. S is 16. Oh, that's positive. Has to be positive. We'll just use place values here. I'll write the answer up here in red. We have x cubed plus 4x squared from here plus 10x plus 12. Okay. And here we'll go 2, 3, negative 1, 1, negative 4, 4, negative 12, negative 8, 0, negative 1, 3, 2, which is 2x cubed minus 5x squared minus 13x plus 4. You see, we're multiplying them out savage quick compared to maybe doing it other ways. That's the power of place value. It's a cube. next term is a square, next term is a linear, and the next term is independent. Too many of these altogether, we'll just do them for practice. First of all, a quick little trick, you don't have to do this, but you could take out the common 2 here. Okay, so we call this 1, negative 2, 1, and multiply it by 3, negative 2, and then just double up our answers. So multiplying, we're getting minus 2, 4, negative 2. With 0 here, we have 3, negative 6, and 3. Okay, now I'm going to do 3 things in my head at the same time. I'm going to add, double, and bring in the power. Add, a double, and bring in the power. Add, double, and bring in the power. Add, and double. Oh, I've gone and crashed my OneNote. Have I? Well, we can just do this linearly because there's the y is taking the place of numbers, and it might get a bit confusing if we don't just do 3 multiplications there and 3 multiplications here, and we'll have a load of cancellations. So let's do the top 3 red ones. What do we get? We get x to the 3 minus x squared y plus xy squared. And the blue ones, it'll be a y x squared, which will be cancelling there. It'll be minus xy squared, which will be cancelling there. And it'll be plus y cubed. So we get x cubed plus y cubed, which is the sum of 2 cubes identity. And just to torture us, they're asking us to do the difference of 2 cubes. So I'll leave that as an exercise. You'll do 1, 2, 3, and 1, 2, 3, and similarly you'll get some cancellation down the middle like we got here. So find the coefficient of x. The beauty of this is we don't have to do the full expansion. So to get the x, all we're concerned with is this product and this product. There's no other way to get x. So you have 6x on this one and 8x on this one, which is 14. Oh, sorry. Yeah, which is 14x. So these multiply together to give us x squared minus x plus 12. We'll call that 1, negative 1, 12 on 2, 1. We get 12, negative 1, 1, 0, 24, negative 2, 2. 2x cubed minus x squared plus 23x plus 12. Now we're going to have great fun on this one because we have a quadratic by a quadratic, which is on the course, so that's good. Not a difficulty for us using place value. Quite a lot to keep track of otherwise. Minus 2, 8, and minus 4. Down your 0, negative 3, 12, negative 6. This time we put down 2 zeros because we're going straight into an x cubed, because this is x squared, straight into an x squared. And now we've gone all the way up to 4s, power 4s, power 3s. Notice for this power 2s you have to add 3 numbers. 13 take 4. Now, if we're finding the coefficient, I'll leave in the variable so you see what I'm doing here. If you're trying to find the coefficient of x squared, we don't have to multiply it all out. Okay, we're going to get x squareds here, here, and here. So, I'm blue. So we'll do this one is minus 15, switch to red is minus 2, and switch to black is minus 30. They're all negative, right? Yeah. Minus 47. And I think they only wanted a coefficient. So that's the answer. X plus 2 and x plus 2 here, provided x is not equal to 0. Because if x was 0, you'd be dividing by 0. So you cannot simplify that to this if x is 0. Mind you, it blows up anyway. If x is 0, you end up with 0 over 0. You don't know where you are. It's missing from the space. You can't evaluate it there at that point. Okay, simplify to the following. 3x squared minus 2x. Again, x has to be 0. What happens here? 3x minus 2y. And x and y are both not allowed to be 0. This goes on forever. This is getting crazy. I hope my recording is working. 2x plus 3y minus 1. And like and I've been doing these a long time. I'm getting tired of it. So this is too long an exercise. But look, here we are. 2x minus 3. No, is that right? X squared minus 3x plus 4. 4a, 4ab. Don't see that, this just runs along like this. 2 into 4 is 2, 3 into 6 is 3, x into x squared has an x downstairs. Y is on his own upstairs. Okay, we'll factorize the top. I'm looking for two numbers. Well, now to factorize the top, I'll have to do a 3. Now 2 3s is 6, take 1. But anyway, the outsides are prime, so it has to be this way or the 3 into 1 upside down. And I'm looking to subtract 6 and 1 to get 5. I like it. I need this to be positive, therefore this is negative. So that goes with that, and you get x plus 3. Okay. I'm definitely splitting the... Well, first of all, let's take out the 2. And you can be darn sure it's x minus 3 and x plus 2, which it is. So x plus 2 is the answer, except it has to be doubled. Again, this is very lazy on their part. That'll turn into 4x squared plus 4x minus 3. Remember, it is a 2 factor thrown in on top now. And I'm factorizing. And there's a 2 factor on the bottom. This is very bad, very lazy question. So divide out the top 2 and the bottom 2, you get 4x squared plus 4x take 3, and you have 2x take 1. So this is the equivalent question. So that tells me I'm going to be using a 2x minus 1 and a 2x plus 3. You see, once I know I'm almost certain 2x minus 1 is one of the factors, and I can figure out the other factor by dividing 2x into that. and dividing minus 1 into that gives 3. So that's the answer. Now, how do we do this? You can use synthetic division, or you can divide the ends and have one indeterminate value. I'll show you what I mean. You divide the ends, giving you x squared, divide the ends, giving you 12, but there's a middle value you don't know. But when you multiply the denominator by the quotient, this by this, you get plus 19x for the x term. So that's just minus b and 12. So 12 take b is 19. So b is minus 7. Okay, so the answer is x squared minus 7x plus 12. I'll do another one over here like that. So I'm going to pop 2x take 1 here. So I know it's going to be x squared because of that divide. I know it's going to be minus 1 because of that dividing. The undetermined value is bx, or the undetermined term. Now I'm going to multiply that and add them together, giving me minus bx minus 2x equals minus 2x, so b is 0. Please let this end. No, the torture continues. Okay, let's drop 3x minus 4 underneath, giving me x squared minus 1, undetermined value. That's worth minus 4b. Let's just take it without the x's. Minus 4b minus 3 equals minus 3. Again, b is 0. And you can double check that. You can say, so x squared minus 1 multiplied by 3x minus 4 must multiply out. To what we had in the middle, which we do. They're kind of been lazy as they're making them up. I think they don't, I don't know. It's just a bit not very interesting how they're making these questions up. Look, I'll show you another method, synthetic division. 1, 0 for x squared, negative 22 for x, and 15 are your coefficients. You make this frame for long division, except you use the factor. You solve x plus 5 equals 0, and you use the factor. The root is minus 5. You add downwards. You multiply this way. Add downwards. Multiply this way. Add downwards. Multiply this way. Your remainder is 0. And it was x squared minus 5x plus 3. Okay. Now if you do it with the unknown, undetermined coefficient b, look, x into x cubed is x squared. 15 divided by 5 is 3, and we would have had a bx here. And I'm multiplying here. You get 3 plus 5b had to be equal to negative 22. 5b had to be equal to negative 25, and b was equal to negative 5. Same result. Okay, so I'll just give you that synthetic division again. 2, negative 1, there's a 0, and negative 12. 2 is the root. This 2 adds straight downwards. You can put a 0 there if you like. 4, 3, 6, 6 plus 12 gone. 2x squared plus 3x plus 6. Here you have a cubic over a quadratic, so you can just divide the ends and you're done. You can multiply it out if you don't trust me. Divide the ends and you're done. Divide the ends, you're done. Divide the ends. Now you can't divide the ends here. I mean you can, but there's an undetermined b value. Now it is two ways of doing this. You can recognize it's the difference of two cubes. So you could use the difference of two cubes identity, which you should be able to repeat. So what we're here is the bases are x and 2. So we're squaring the base. We're multiplying the bases. So that's what you're going to get. Now there's lots of ways of doing it. Okay, luckily we're finished on them. So thank you for watching. Hope you picked up a lot. See you in the next one.